All right, so we are now at the operation of subtraction. So we're going to continue our series where we're illustrating the working of the negative sign. This time we're dealing with the mathematical operation of subtraction. So let us start with subtraction where the both entities that we're operating on are positive. 1, 2, 3, 4, 5, 6, 7, 8, 9. $9. So we have $9 physically present here. And if we take 6 of those dollars out of the picture, we take away $6. So in other words, you have $9 and then you have to take $6 to pay something. Whether it's a debt, or you just decide to buy something, or you decide to give away something, or maybe you decide to lend somebody $6, or maybe there's a service charge in the bank, or something of that sort. Right, 9 minus 6. 1, 2, 3, 4, 5, 6. 9 in your hand, 6 gone. Leave you with 3 in your hand. We understand this, we know this, we comprehend this. Consider the reverse. Let us say that you have, we just know we did 9 minus 6. Now we're looking to do 6 minus 9. Right, so let us say that you have $6 in the bank. $6 in the bank. Right? And you know how the bank charges go. $6 in the bank, and then one day you check and you see minus $3 in the bank. That could have happened if it was a situation where the bank, through whatever mechanisms and through whatever processes and whatever things that they have. You know, the banks have all these things. They take $9 out of your account. Right? So you have $6, the bank take 9. Well, if you have 6 and the bank take 9, now we have a situation where you have 3 missing still because they only had 6. So you have 6 gone. But the bank take 9, which means that they still have 3 that they're waiting to take whenever that 3 come. So as soon as that 3 come, it's gone. Right? That would show up on your bank statement as minus 3. Right? We have all seen these situations already in varying amounts. Right? You have a certain amount, the bank take a little more than that for whatever reason. Right? Maybe you pay something or whatever it is, and boom, you end up with a negative. Yeah. Right? So we could illustrate those two scenarios. Right? 9 minus 6, pretty straightforward. $9 in hand, you take away 6 is equal to 3. Or, alternatively, you have $6 in the bank come and take 9. It means that you still have 3 more that they're waiting to take. You're still in deficit by $3. That's one scenario. Let me switch to another scenario now. Suppose you have $9 in the bank. Now listen to this one carefully. Yeah? Suppose you have $9 in your hand, or wherever you have it, in your wallet, in your back pocket, in a box under the bed, something along those lines. And in the normal course of things, you would have been operating under a situation where you have 9 interacting with a debt, or a taking away, or a removal of 6. And watch it now. For whatever reason and in whatever circumstance, you now reverse that process. Remember, we discussed the negative sign as an indicator of reversal. Something is being reversed, something is being done opposite to how it was normally done before, or how it is usually done. So instead of taking on the debt, or taking on the deficit, or adding, right? Or instead of a situation where the money leaves your account, we reverse that. So instead of, let me demonstrate it with the money, man. So instead of, you have $9 here. 3. Right. So instead of $6 leaving the $9 that you already have, you reverse the scenario and now we have $6 coming into the $9 you have. See what I did? Let me go through, let me do it again. 9 plus minus 6 means that $6 leaving the account. Right? That is the situation. The situation is $6 leaves. Now, instead of $6 leaves, we reverse. This minus sign here means that you're reversing. You're reversing the scenario where $6 leaves. And now, instead of $6 leaving, you have $6 arriving. That is 9 plus 6, which will give you a 15. Right? So you have minus minus. This would be 9 plus 6, which will give you 15. Right? And by the same token, if you have $6, right? So in other words, this is a reversal of this, as you can see. And you can see it even clearer here. This is a reversal of this, because instead of $9 leaving, which would be 6 plus minus 9, which will simplify as 6 minus 9. So you start with 6, right? You start with 6. Again, money in the bank. Right? 4 and 2, 6. And instead of $9 leaving, which would be this 6 gone, and then you have 3 more to go still. Instead of taking 9 from 6, see? 6 minus 9. We reverse this scenario. Again, the minus sign, this minus sign here is an indicator of the reversal of this condition. So instead of having $6 and having to lose $9, meaning you lose this 6 and you still have 3 to lose whenever that 3 enters your bank account. Instead of that being the case, now in a situation where, having reversed that situation, you now have a situation where you start with 6. And instead of 9 leaving or 9 being taken away, $9 is added to the 6, or $9 comes to the 6. So in other words, the $9 coming to join the 6 as opposed to $9 leaving the 6, as we just had before. So again, we understand intuitively, if you start with 6 and $9 enters the picture, 6 plus 9 is still 15. And having discussed it under these circumstances using the minus sign, then that would devolve into 6 plus 9, which would be 15. All right, so, and again, you see the multiplication showing up, right? We already discussed previously that minus multiplied by a minus is a plus. Minus by a minus will give you a plus. Even in circumstances where the two negative signs mean two different things. In both of these cases here, this negative sign signifies a particular action. An action, the action of reversal, you're reversing something. This minus here means a debt of $6. It means $6 leaving your account. Same story here. This negative sign in front of the 9 signifies $9 leaving the account. So when you reverse $9 leaving, basically you have $9 coming. When you reverse $6 leaving, you have $9. Sorry, when you reverse $6 leaving, you have $6 coming in, which means that you're adding 6 in this case, and you're adding 9 in this case. So in other words, The concepts a little abstract. It might be a little tricky to explain, but when you really think about it, once your definitions are clear and you are consistent with the definitions that you define, then the rules work and you could apply what we would refer to here as book sense to your common sense, and you see a correlation between the two. So book sense and common sense are not mutually exclusive as some people want to believe. They think you either have book sense or you have common sense. How about both? How about both? Especially now that we're living in a world that is becoming increasingly technical. Everything that you could think of is getting technical. Your phone is no longer just a simple thing to pick up and talk. You have all kinds of functions on the phone, digital functions, right? Your vehicles, yeah, right? Your TV, your camera, your banking is no longer just you walk in and you do your thing. You have online banking, you have all kinds of things. Everything is digital, everything is technology, everything is computer. And what a lot of people don't get is that the competent manipulation of this environment is enhanced by some kind of mathematical understanding, right? You find that there's a very direct correlation between folks who take the mathematics seriously and folks who could manipulate the technological environment. And it always changing, right? So just to deal with that change alone is a particular mindset, right? And yes, there are many folks who didn't pass maths and they're doing well with the technology. But the thing about it is that they're applying the maths and they don't even realize it. There's a certain kind of mathematical thinking that goes into the application and the use of technology. Sometimes you have a case where some people are afraid of the technology. They're intimidated. They're probably not confident enough. So they back off. The same way they would back off of the maths, they back off of the technology. And sometimes, just like with the maths, with the technology, it just means sometimes you have to take a little time to learn it, make a few mistakes, you come again. Sometimes you might need somebody to show you. Just like the maths, some folks will take a little longer to catch the technology, but it is becoming increasingly the case where the technology is difficult to avoid. Right? You can avoid certain things up to a certain point. But even if you're not on social media, at some point you're going to have to send an email. Right? If you're dealing with a lot of office stuff and documents, at some point you have to deal with a printer. You have to deal with a scanner. You have to deal with the format of a file. You have Word, you have PDF. Right? You're dealing with photography. You have different elements of editing pictures that are inherently mathematical in nature. Right? Things like your aspect ratio, things like your temperature, right? All kind of different things. The whole point I'm making is that the mathematics will become harder to ignore. The world is not as simple as it used to be, right? So it behooves us to get on board with the maths. Don't think that because I'm not measuring angles in my daily life, I wouldn't need Pythagoras theorem. The things and the thought processes that it will go through to manipulate Pythagoras theorem, it will show up in other areas of your life. And as I tell my students all the time, some of those areas might be areas where the stakes are higher, in some cases significantly higher than just passing an exam. So don't take it light. Maths is serious business. It's not just about passing an exam to get a whack, as we say here in the Caribbean. It's serious. So take it serious now, right? Right, so we're going again. You know, every time, sometime we're talking, we have to interject, right? So we're going again. Minus 9 minus 6. Minus 6 minus 9. You have a debt of $9. 1, 2, 3, 4, 5, 6, 7. Right? You have a debt of $9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So $9 gone. And then you pile on another debt on top of that. So in other words, you're minusing 6 now from the original minus 9 that you had. So in other words, you're going further down the road, right? And again, we could understand it in terms of money. Because if 9 had to leave, that is minus 9. And then 6 had to leave, that is minus 6. Minus 9, minus 6, minus 6, minus 9. So in a circumstance like this, you're getting a very clear sense that minus 9 minus 6 is actually the same thing as minus 9 plus minus 6. And vice versa. Minus 6, gone. Minus 9, gone. Minus 6 minus 9. Minus 6 minus 9. Is the same thing as minus 6 plus minus 9. Right? If you already know that minus 9 is 9 leaving. So, as you get deeper into this thing, you realize that there's a certain sense in which all of the things start to merge and converge. And you realize eventually, whew, let me clear the board, boy. Right? Ay, ay, ay. You realize that, watch it now, and watch it again. You have a bank account. Again, we're dealing with money, bank account. And you have a payment of minus 9 to make, whatever you're paying that to. Right? Marker boy. Come black, right? Minus 9. And then from the minus 9, you're taking minus 6. So you're taking the 6 from minus 9. 6 from minus 9. You're taking the minus 9, that gone. And you're minusing 6 from the minus 9. So in other words, you're adding a next minus 6 to the minus 9. Alright? So this is the same thing as minus 9 plus 6. Right? You start to feel it. And that's what I wanted to do. I wanted to feel it. Even in the situations where it might be difficult to explain logically, you start to feel it. Minus 9 minus 6, minus 6 minus 9. And again, a lot of things in life like that. Certain things you could feel. Sometimes you feel it long before you're in a position to explain it. You can't explain it, but you feel it and you know it. Right? Same thing, minus 6. You have a debt of minus 6. Minus 6, gone. Right? And instead of adding 9, you're taking away 9 from the 6 that are already taken away. Which means that you're taking 9 more from the 6 that are gone. Which means that you ended up taking 15 away in total. So whatever you have from the beginning, you take 6 from that and then you take 9 again. Which is the same thing as minus 6 plus minus 9, where you're adding a removal of 9. So in other words, you're removing 9 from 6. So you're starting to get a sense now where sometimes the thing not as easy to visualize. You take 6 and then you take 9 again. But again, if we use the ubiquitous tool of money, it is something that we could feel, because we are so familiar with it that we know that that is what it is. So we know that if we lose 6 and then we lose 9 again, we lose 15 in total. Or if we lose 9 and then we lose 6, we lose 15. Same thing. And then we go on to the next set now, where we're starting off with a loss of 9, right? But having lost 9, instead of a situation as we just had where you're losing 6, now you're reversing the loss of 6. See what you see? Reversing again. So you're reversing a situation where you're compounding the original loss of 9 by a further loss of 6. And instead of losing 6, you're adding 6. And if you lost 9 and you add 69 at a loss, you're still in deficit by 3. Right? You still have a lost 3 then, so to speak, that you had to deal with. Right? So something just occurred to me. Let me say you're a shepherd with sheep, right? And you have 9 lost sheep. And in the previous example, 6, you lose 6 more, that's 9. And then you lose 6 more, that's 15 sheep lost. But if you lost 9 and 6 of the sheep come back, right? 9. This 6 were also lost. But instead of losing a further 6 return, then you have 9 plus 6, which is now you still have 3 sheep outstanding. So I deviate from the money for a little bit, but if I want to be absolutely technical, in some societies they use sheep and livestock as money. So we ain't so bad. Right? So if I lost 6 sheep, in the previous example, we would have lost 9 more to have a further loss of 15 sheep. Sorry, a total loss of 15 sheep. But if instead of a loss of a further 9, we reverse that. So now instead of 9 sheep being lost in addition to the 6 that they had lost before, you're now reversing the loss of 9, which means you have 9 sheep coming in. So having lost 6, 9 coming, it means you have 3 extra sheep now. You see? We could understand the thing in simple scenarios. So that what you actually have is minus 6 plus 9, which would be plus 3. Right? Let me deal with money. That is where we started, so that is where we will end. $9 gone. Instead of losing a further 6, you reverse the loss of a further 6. And instead of losing 6, you add in 6. So this minus minus here signals the reversal of a loss, which now be a gain. So instead of losing 6, you gain 6. So 9 plus 6, you still have 3 outstanding. That is dollars. Right? Let me see, boy. 9, 1. Some concepts harder to illustrate than others, but when I could do it, I do it, eh? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 gone, and instead of 6 going, which would be 9 gone and 6 gone, is 15 gone. 9 having gone, 6 return, which means you still have 3 outstanding. Yeah? Right. On the other hand, if 6 gone, 1, 2, 3, 4, 5, 6, boom, 6 gone, right? And instead of losing a further 9, this is minus 6, instead of having minus 9, we reverse the minus 9 and that is now plus 9. You see? So the reversal of minus 9 means that you're now plus in the 9. So 6 gone, 9 come back in, which means that 6 having gone, the 9 will be comprised of the 6 that went out. The 6 come back, and you have 6 plus 3 is 9. So you now have an extra 3 that you didn't have before as a result of the 9 coming in, subsequent to the loss of the initial 6. You see, we're trying all how to explain this thing because I want people who need the discussion to have the chance, if they're willing, to sit down and listen to my boring explanations. Sometimes it just be boring. Me, I have no problem with that. I claim that and I own that. It wouldn't be exciting every day, right? But if you're willing to put yourself through that, as with any other thing in life, where you're trying to achieve a particular outcome, you make the progress that you need to make. All right? So let me discuss some general law. And again, quick. You're seeing again the multiplication. Minus by a minus is a plus. Minus by a minus is a plus. Again, it is easier to spot this and it is easier to appreciate this if you would have gone through the multiplication before. Because having done that, we know that minus multiplied by a minus is a plus. So we could consider it as multiplication, right? You have a minus sign outside the bracket and a minus sign inside the bracket. And yes, in mathematical terms, that is multiplication. So even though the actual situation in words is not a situation of multiplication, in this case we're talking about a reversal. When we start to use the written language of mathematics, when we start to use our numbers and our symbols, we find that the mathematical operation of multiplication will in fact provide an ample and a sufficient explanation of a situation that may not necessarily be an actual situation of multiplication in real life. So in other words, we're using in mathematics as a tool. We're using in mathematics as a language to communicate the working of a situation that may not necessarily be a situation of multiplication, but we're using a mathematical tool of multiplication to explain it. That is how the maths is. So sometimes when you're trying to understand the thing, you have to think deep and you have to think hard and you have to think long. Sometimes you could just accept it. You take it that minus by minus is a plus and you run through it. And a lot of us do maths like that, and that's fine. Sometimes you just take things as they are given to us and you put yourself in a situation where you could function. It doesn't necessarily mean that you have a deep understanding of it. And that's okay. We wouldn't always have a deep understanding of everything that we do or every tool that we use, right? But as somebody who is trying to teach the thing, I take the responsibility of doing as much as I can to explain it. Because you teach something for long enough and there will always be a student or some students who will ask the hard questions, the things that are difficult to explain. And there are circumstances where, as much as they try, you really can't give the answer at the moment. As a teacher, sometimes you as a teacher yourself, you don't have the answer. You just know what the tools are, and you could function with the tools. Sometimes you don't even have a full understanding of the tool that you're using. Have teachers like that, no problem. But they could still transmit the information. And if the student is receptive to receive the information without the total 100% understanding, we can make it work. But for those of us who want at least to have some level of trying to understand it, and there are people like that, they will not progress in the maths if we don't make some little attempt to explain the thing. And then there are those who doing it, but if you show them it, if you show it to them, and of course we're assuming that they're willing to have it shown to them, you show it to them, and a light bulb goes off in there, and it's like, okay, I now understand this thing. And having received that extra understanding, it takes them to a different level in their own practice of the maths. So don't take these long, tedious, boring, exhaustive and exhausting conversations for granted. Yes, we know everybody wouldn't listen to most of the videos, but I'm putting it out there still. So for those of us who decide to take the time and listen and watch, whatever it is you had to get, you had to get. So let me just conclude with a little wrap up in terms of some general relationships where we're subtracting, right? Under the operation of subtraction, where the negative numbers are concerned. All right? So, general thing, and I think we would have discussed this in an earlier video, but we're going through it again, right? A minus B, let me say A minus B is equal to C. If A is greater than B, C will be positive, right? So, and if, sorry, let me say that over. It's not just a case where A minus B is positive, right? Forget that. A minus B is equal to C, then watch it. B minus A is equal to minus C, right? We saw that when we spoke about 9 minus 6 and 6 minus 9. So yes, 9 minus 6, 9 is greater than 6. You see is positive. Well, if we start off with that, then if we reverse the placement of the numbers and we put the smaller one first, then the answer will in fact be the negative of what they had before. So, and I want you to listen to this very carefully. Unlike addition, the operation of subtraction is not commutative. Let me repeat that. Unlike addition, and we saw that in previous discussions in this series of videos, unlike addition, the operation of subtraction is not commutative. The answers are close to each other but not the same. And depending on the circumstance in which you find yourself, you might find that there's an entire ocean of difference between plus 3 and minus 3. So don't even go down the road of telling yourself, well, 3 and minus 3 close to each other. They're not close at all. Plus 3 is plus 3 and minus 3 is minus 3. And anytime you think that plus 3 and minus 3 are close, just go back to your good friend. Money. Money. Right? Plus 3, money coming into your bank account. Minus 3, money leaving your bank account. It have nothing close about that. Right? Yeah. Right. So addition is commutative. And again, let me just give the quick examples, right? We saw that 9 plus 6 is equal to 15, and we saw that 6 plus 9 is also equal to 15. But because of what we have over here, 9 minus 6 is plus 3. 6 minus 9 is minus 3. Not commutative. So multiplication is commutative, addition is commutative, subtraction is not commutative, division is not commutative. So I will probably have to do a video where I'm discussing that in a little more detail with some examples, of course, right? That will probably just have to be a video on the commutative law, right? These things are important to understand when you're dealing with facts and, sorry, not facts, with figures and negative signs and letters and substitution and algebra and all of them things. And yes, depending on the circumstances, these things may in fact manifest as facts, but we get in a little outside the maths when we go down there, right? Nice. So there's that. That's one set of relations, right? In black, right? This here is just the example. So if A minus B is equal to C, then B minus A is equal to minus C. In other words, the subtraction is not commutative. For the subtraction to be commutative, B minus A would have had to be equal to C as well. So, no. Important to understand. A minus minus B is the same thing as A plus B. Minus by minus is a plus. And by the same token, B minus minus A is equal to B plus A. So over here we're commutative, right? Over here we're not. But because this multiplication gives you an addition in both instances, minus by minus is a plus, minus by minus is a plus, you end up with A plus B, you end up with B plus A, we know that the addition is commutative. Yeah? We're going again. Minus A minus B is equal to minus into A plus B. So you add the A and the B and you put a minus sign in front. So minus 9 minus 6 was minus 9 plus 6, which is minus 15. By the same token, minus B minus A, as a A not a 9. Minus B minus A was minus into B plus A, right? We know that A plus B is equal to B plus A. That is the commutative property of addition. But you only get there at the very end, not over here. So minus 6 minus 9 is minus into 6 plus 9, which is minus 15. Minus 9 minus 6 is minus into 9 plus 6, which is minus 15. You have to go right through with the thing. It has no shortcut out here. Right? Right. And the last one, which would be, yes, minus A minus minus B is equal to minus A plus B, which is equal to B minus A, or minus B minus minus A is equal to minus B plus A, which is equal to A minus B. So in other words, you cannot make any assumptions about the commutativity or lack thereof until the very end of the sequence of steps. Right? So we have A plus B here and B plus A here arising out of these two steps. You have minus into A plus B, minus into B plus A arising out of these two steps. Those are the situations where no matter how you switch the numbers, the answer will end up being the same. Right? But the commutativity only enters the fray at the very end here. All right, nice. So with that being said, we are now at the end of this series where we would have spoken extensively about the negative sign. It was a long process. It was a tedious process. If you are one of the very, very small minority, I'm sure, who would have looked at all of the videos from the beginning to the end, you see how long it was and you feel how long it was. Imagine what it was for me in terms of thinking about how to explain the thing, doing the videos, having to take multiple takes, right? Take 1, take 2, take 3, the editing. And apart and aside from all of that is the work involved in putting the written exercise together that goes with these videos that will allow you to practice, which is the most important part of the sequence of events. Yes, you listen to me. Yes, you understand me. But beyond that is you know. You have to take the time. You have to make the time to practice. So if you are one of those people for whom the issue of negative signs is a problem, with this series of videos and the associated exercises from me, you have an opportunity to do the necessary work to get a clear sense of understanding, to get a clear sense of knowledge, to get a clear sense of rhythm, to get a clear sense of the flow, to get a clear sense of the timing, to get a feel of dealing with negative numbers. And I want to strongly encourage, if you have any weakness at all where the use of negative numbers is concerned, under the basic operations of multiplication, division, addition, and subtraction, you will be well served to take your time and make sure, because the use of negative numbers is something that you will have to employ as you go further into the other topics in mathematics. All right, so that is it. I trust that you would have experienced some level of edification, whatever your level of participation was. Right? I know that everybody wouldn't have looked at all the videos, but that's okay. Whatever you need, you take it. And if there was something that he needed that he didn't take before, then you just go back and take it. All right? So, all the best in your mathematical journey. Stay tuned. We have plenty more to offer.